Okay, so yeah, we'll just call this set B. Okay? Doesn't mean it's a vector space, it means we're testing it to see if it's a vector space. I use V. Okay, so if you add these, you get x1 plus x2, y1 plus y2. Is that a member of V? Well, what's the criterion? You square the first component, square the second component, add them, you got to get 1, right? Okay, well, let's see. Is x1 plus x2 quantity squared plus y1 plus y2 quantity squared equal to 1? Well, how can you prove that? How can you prove that it isn't necessarily? I'm sorry?
Plug a number in.
You could plug numbers in and probably, well, are you going to be able to find numbers such that x squared plus y squared is 1?
0 and 1.
0 and 1, okay, so you could use specific numbers, okay, but I'm going to be a little more abstract. Pretty much any two numbers you choose that satisfy this, like 0.6 and 0.8, which you should know perfectly well, or okay, and you put them in a different order over here and make one of them negative, one of them positive and stuff. Well, okay, one thing we can do, okay, the most direct thing I could say is, well, there's no reason x2 couldn't be the negative of x1, is there? And y2 could be the negative of y1, right? In which case, these things add up to 0, right? So clearly, it's not going to be so. And almost any example you come up with, it's not going to be so. Because we want to look a little deeper. We can get our algebra up to a little higher level. This means x1 squared plus 2x1 x2 plus x2 squared plus 2, well, y1 squared plus 2y1 y2 plus y2 squared equals 1, right? So if we didn't immediately see to just pick some numbers and work it out, we could look at this expression and ask ourselves, well, is it got to be true that this expression is 1, right? And then we would maybe, hopefully, look at the fact that we've got x1 squared plus x2 squared, which is 1, right? And we got y1 squared plus y2 squared, which is 1. So now we have 1 plus 2x1 x2 plus 1 plus 2y1 y2 equals 1, right? So two times, I'll just factor the 2 out of the x1, x2 plus y1, y2, right? I factor, well, I can't say that exactly right, but you know what I mean. Plus 2 equals 1, right? Okay? Well, not so unless x1, x2 plus y1, y2 equals negative 1/2. Because the only way this is going to add up to 1 is if this is negative 1. Which means 2 times this has to be negative 1, which means that this has to be negative 1/2, right? Okay? And it's just not necessarily so. You could go from there. You could do the algebra, and sometimes you got to do the algebra, okay? Turns out here you can just find counterexample by inspection and prove that this isn't always so, okay? Now, sometimes it is. Now, it's very possible that x1 times x2 plus y1, y2 could be -1. There are plenty of combinations that would give you that, okay? Well, you don't have to go this deep, but I wanted to at least do that to show you the kind of algebra you can get into. Okay?